I don't think people understand just how much unsupervised learning shapes our daily lives. Hi, I'm Pankaj Sharma, and today we're diving into a world without labels. Ever wonder how your streaming service predicts your next favorite show, or how your bank spots fraud instantly? It's not magic, it's unsupervised learning. In unsupervised learning, computers get a pile of messy data, no labels, no hints, and are told, find something interesting. Unlike supervised learning, where a teacher labels cats and dogs, here the computer explores on its own, searching for patterns and structure. It's like a detective sifting through chaos, grouping similar things and discovering the hidden order in data. This approach powers everyday tech, from organizing your photos to helping scientists classify stars. The magic? We don't tell the machine what to look for, it shows us what it finds. So forget strict instructions. The computer becomes an explorer, mapping the unknown. Let's start understanding this with a simple example: sorting toys. Imagine a messy toy box, cars, blocks, action figures, all mixed up. You want to organize it, but there are no labels. So you make piles, cars here, blocks there, figures in another. That's clustering, grouping similar items based on their features. Clustering algorithms do the same with data. They sort points into groups where members are similar and different from other groups. The computer doesn't know what a car is, it just finds patterns in the data. Sometimes it groups by color, sometimes by size. It depends on the features. The power of clustering is finding natural divisions in huge, unorganized datasets. Suddenly, millions of data points become a few understandable groups. This is the first step in turning raw data into real knowledge. So, how does a computer actually cluster data? Let's look at k-means, a classic algorithm. First, you pick a number, k, the number of groups you want. The algorithm drops k-random centroids into the data like magnets in a toy box. Each data point is assigned to its nearest centroid, forming rough groups. Then the centroids move to the center of their assigned points. This process, assign, update, repeat, continues until the centroids stop moving. The result, stable, well-defined clusters. K. Means is simple, fast, and works well when you have a rough idea of how many groups to expect. It's the foundation for much of unsupervised learning. Now, let's see how clustering changes the real world. Clustering isn't just theory, it powers real-world solutions. Businesses use it for customer segmentation. Algorithms find groups like bargain hunters or high rollers, so marketing can be targeted and effective. Banks use clustering for fraud detection, flagging transactions that don't fit your usual spending patterns. It's used to organize news articles, classify new species, and even help city planners spot traffic problems. Clustering turns overwhelming data into clear, actionable groups. It's a silent guardian, sorting the normal from the suspicious. In every case, it helps us make sense of complexity. That's the real magic, finding order in chaos. But k-means is just the beginning. K-means is great, but clustering has many tools. Hierarchical clustering builds a tree of groups, letting you decide how many clusters you want later, perfect for exploring unknown data. DBSCAN finds clusters of any shape and spots outliers, ideal for fraud detection or noisy data. Gaussian mixture models go further, giving probabilities for each point belonging to different groups, useful when data overlaps. Each method uncovers patterns in its own way. The world of clustering is vast, with a tool for every kind of data. It all starts with simple sorting but leads to powerful discoveries. The journey from chaos to clarity is just beginning.